Hi, and good morning. We're going to go ahead with the structures section on here. And I guess the first thing we need to do, let's get this out of the way. And learning objectives and what we're going to be trying to remember when everything's done. All right. Now, I know it says inspecting the footing and the foundations. I get that. We're not going to really be able to see those items. But nonetheless, I want you to be, aware of how they're supposed to be installed properly so that when we're looking at things, we can make sure that we're looking at them properly. Same thing with the different types of foundations. We are expected to be able to identify the types of materials, conditions, safety issues, and other things that are going to be involved with it. All right. Safety first always comes into this. And then, and I'd also like to tie this into our standards of practice and what the Illinois law has to say what we have to do as well. With the Illinois law, it says we have to inspect what the foundation, what the structure is, all right? It says that we have to describe, which means we put in writing in our reports, how we inspected the attic and how we inspected the crawl space. It doesn't say we have to enter the attic or enter the crawl space. Now, part of what I do with these things is give my suggestions, all right? And it's completely 100% your choice, as long as you're following the law. But truthfully, getting into the crawl space, getting around in there, as best as you can, is going to be your best view of everything. Trying to take a picture from the hatches isn't always, it just doesn't do your client complete justice. But I get it. Sometimes it happens. I'm a big guy, and sometimes these holes are small or the height available isn't really there for people to get through it. So if you're limited, you're limited. And with the amount of money that we actually make on each inspection, I'm going to encourage you not to do stupid things and to start realizing that sometimes going into these areas isn't really healthy. It's not too smart, all right? So, the common sense one is the collapse stuff, all right? If you see walls leaning or floor joists that are broken and rotted so bad that they're starting to settle and drop, what reason would we have to put ourselves in a situation like that? That's enough. This is bad. Get it fixed and then get somebody to go further on. If somebody wants to find out more about those areas that are bad, look for different ways to go ahead and get pictures or views where you're not going to be risking your life for a measly $300, $400, $500. It's just not worth it. All right. The standing water may not seem like a big deal, but it doesn't take much of a cut or an opening in your skin to where you can get a staph infection. We don't, when it comes to standing water and it becomes stagnant, there's a lot of bacteria growing into those things. And if and staph infection can cause you to lose a limb, and it can also kill you if it's left to go unknown. So electrical shocks in crawl spaces and even up in attics, you start seeing people do some really unusual wiring when you're up in those areas. And I get it. Somebody who's installing a fan or maybe a light and it's super heated up in the attic, they don't want to spend any more time that's necessary, so they do what they can to, get those wires tied up, get the power flowing, then get the hell out of there. Same thing in crawl spaces, especially if there's mold or other issues that are growing in there. You are going to come in contact with animals. Hopefully you won't be face to face. If you see them, I assure you, they're going to be scared of you. There's no reason to approach them or get anything close to them. You're done. Back out. Wearing the proper protective equipment, this would be something that I was negligent for many years, and it was just outright stupid, and I don't have a better thing to say. But, stuff like knee pads, when I started this 28, now that we're in 2021, that was 28 years ago is when I started this whole home inspecting thing. I never wore knee pads. I was a young pup and I had pretty strong things coming in there. But now that I'm a little bit older, my knees hurt. And crawling on these things is not a fun thing anymore for me. So if I wore knee pads, I think I could have extended the life of that stuff. And same thing with Tyveks and gloves and different things that I could do to keep all this insulation, stagnant water, anything away from my clothes, my body, any other irritants or poisons that are in there. All I'm asking is that you please take consideration of it. Wear the mask, wear the helmet, wear the goggles, all right? I'm still going to confess that I'm not very good at it, all right? This is more of a do as I say, not as I do. But every time I go there, I keep thinking about me preaching to other people, don't be as stupid as I am, all right? And I need to start picking up my game. And I have been, but I need to pick it up even further. And wear that mask, make sure I don't inhale that insulation. I mean, I'm not a scientist when it comes to stuff, but I really don't think fiberglass dissolves or is absorbable by the lungs. All right, I know asbestos, when it's friable, that's definitely not, and we don't know what's in those areas. So why take a chance of any of that stuff entering your lungs? All right, enough of me preaching. I apologize for that, but I still think it's important. I shouldn't apologize. I'm sorry. It is important. So basics of structures, all right? There's one thing that we have on this earth, and it's called gravity. So everything wants to be pulled towards the center of the earth. And it's our job to, as constructors of buildings, to make sure that that gravity doesn't pull those buildings down to the ground, all right? So 3 ways that the structure is given to gravity. It's going to be the ground below it fails. Typically, that's going to have to do with water coming in there. So whether it's water that's seeping down underneath and ruining the earth below it, or there's actually bad earth below it already, and they just didn't know it, and the building starts going. All right. Number 2, the skeleton of the structure is weak. Now, that might be weak from initial construction because somebody built it with small lumber, or it could have been infected by termites or wood rot, any type of issues like that, and that made the structure weak, in which case it's going to start squishing, collapsing, and so forth. And then obviously if somebody puts too much weight on something, more than what it was originally designed for, that something's going to want to be taken away and be gone. All right. Some words that you should have a good definition on and an understanding, and everything comes into play under these words, and we're going to be using them over and over again. Compression, tension, shear, and bending. I think bending is kind of self-explanatory. Anytime we take something and we squish it or whatever and it starts to bending, it loses strength, especially if we're stacking lumber and it starts to buckle or bend like that, then the weight of it is just going to cause it to keep getting worse. But the first 3, compression, so that means squishing, putting things together, all right? When we build and we start looking at the structure and how we put all the wood and everything together, you're going to find that we stack lumber when we build by houses. Stacking is the best way. Most of the lumber materials we use are pretty strong in compression, all right? But I like to take concrete, for example, because concrete's one of those items that's strong in compression, which means pushing together, but yet it's weak in tension, which means pulling apart, all right? So we have to mix different materials together in order to make something strong in compression and tension. So if I take a long piece of rebar or steel that's narrow, about a 1/2 inch, that's going to be very strong if it's straight. That's going to be very strong in tension. It's going to, if you take a piece of any steel, no matter how thin it is, and you try to pull it apart, even little wires, when we come with it in copper, and we try to pull those apart, it takes a lot of pressure because it's so strong in tension. Now we take a bigger, thicker piece of steel, we're going to have trouble pulling that apart. Now that steel is also very strong in tension. I'm sorry, very strong in compression. If I take the two ends and I push it in like this, as long as I can prevent it from bending, then it's very strong in compression. But however, if I allow it to bend, now it becomes weak in compression. So when I take that rebar, that steel, and I mix it with concrete, that concrete stops it from bending. That gives it additional strength in compression. The term shear, I like you to think of like scissors, and that's why that graphic is up there. Shear is slicing, all right? So we use fasteners that are also strong in tension or strong in shear. For example, bolts, nails. Those, when we put them together, they're much stronger in shearing. All right, they're going to keep two objects from sliding on each other. Screws, for example, drywall screws. They're more stronger in tension, for things pulling away. Nails are weak in tension. So when wood shrinks, we're going to find the nails actually come loose in there because they're easily pulled out. Where screws are very difficult to pull out once they bind in there. All right. So compression to squish things together, tension to pull things apart, shearing to slice, and bending. Well, I don't have another word for bending. I think it's self-explanatory. So here, going over what I was saying before, if we use the fasteners in the intent or how they were intended to be used, it makes them stronger. All right. So if I got a wall or a floor joist and I put two nails in the bottom, but I'm not resting that bottom plate on anything. For example, if this is a header over a closet way that's on a non-load bearing wall, all right, then I go ahead and just take those little the jack studs in there, or the cripples, and then I put a header underneath it. We know it's not holding any weight because it's a non-load bearing wall, but I just need to have a finish going across the top, all right? So I just nail it up there, and I'll have drywall and everything else, and it'll probably be just fine. But if I take that same support that I'm using for the opening done on the left side here, and now I take this here and I hang a heavy bifold sliding glass mirror door on it, well, that puts a lot of weight on that. And those nails don't have that tension strength that's able to be held onto it. All right. So there's a chance that could end up pulling those boards down there. So why even take the chance? Whereas if I had a bifold doors and they're just sitting on the ground, their weight's down below them, and they're not going to be leaning in there, I'm not pulling down on that at all. On the right-hand side of the picture, we're showing the nails installed in shear strength. So the nails are going to be stronger holding the wood up in that position as they are trying to hold everything on the underside. So when we look at structures, and I'd like to talk a little bit about the history of this picture. I'm hoping if you're watching this, you're kind of looking and go, are you showing me that you got brick being used as floor joist on here? And the answer is yeah, we actually are. And I like this picture because the lady that I had draw these and do all the artist work with it is from Mexico. All right. And the United States and Canada are really the only two countries that build our homes with wood frame structures. Everybody else in the world, at least everybody else that I'm aware of, they pretty much, if they're going to build an enclosed home, everything is in concrete. Even the floors are all concrete when it comes with it. So this lady's just used to concrete floors for everything else. And she wasn't aware that, we use wood. So when she put this up there like this, even though it's incorrect, I actually liked it because it just kept reminding me about how the United States and Canada, how we're a little bit different than the rest of the world when it comes to our building techniques and how we do things. But the main purpose of this stuff is to take the weight that's inside, the dead load and the live load. And to be clear, you should know those two definitions as well. The dead load is the weight of the structure. the weight of appliances, the weight of furniture, anything that's, well, not necessarily furniture, but anything that's permanently installed in that building. So if it's a rooftop air conditioning unit or a water heater on the second floor, that's all part of the dead load. So it's permanently installed, it's meant to be there, it's part of the weight and so forth. The live load are the other things that we bring into it, the people, the furniture, everything else where it comes into it. And we're going to put weight on everything. Even the snow up on the roof in the winter months, that's more of a live load, that comes in there, or a shock load when it comes in there. And the purpose of all that weight is we need to bring everything down to the earth. So we're going to take items, and let's say we have snow up here, and this puts weight on the roof. That needs to go down the roof and get to my exterior walls, but we got to prevent those walls from being pulled out, so I need the ceiling joist coming in here to keep that from happening. I need to prevent this rafter from bending in there, so I'm going to tie that with a collar tie on the other side, so we'll go ahead and prepare each other or protect each other. And then we're going to bring that stacking lumber all the way down till we get to our footing, and now we're finally stretching on the earth. Let's say I wanted to put a piano in this room here, so I put it in the middle of the floor. I'm going to horizontally transfer that load down to wherever my columns or support posts or foundation walls. And again, the big ultimate goal at the end, get it down to the earth and make sure that everything's supported so we don't change the shape of everything. The clues that it's not working the way it's supposed to be happening: bending, shifting, leaning, cracking, breaking, anything that's not straight, true, and plumb being directly up and down, level, horizontal. Those are going to be things we're going to want to be looking for. All right, let's get into the different types of soils that we're going to run into. And I guess I'm missing on that one here for a second. All right. So one of the soils, and I think it's going to show up here in a little bit, at least I hope it does, otherwise I need to apologize, is something called expansive clay or expansive soils. I'm told it exists in Illinois. I personally have not seen them or any issues where it comes with it, but I think this more exists in the dry climates. You go to New Mexico, Arizona, places where the earth and the moisture inside the earth in those areas dries up so much that everything starts cracking. And when that happens, you get these gaps in the earth. And then those gaps, with wind and dirt and debris, those gaps start getting filled in with more dirt, more debris, more whatever. And we don't have that air to allow that soil to expand. So when things get dry, they shrink. When things get wet, they expand. When things get cold, they shrink. When things get hot, they expand. All right. So water, things want to grow. And think about a dried out sponge sitting on a counter. It's all shriveled up. But once we get it wet again, it goes back to its original shape. So now we take the earth, it's all dried up, we get that alligator cracking in the earth. Now all those gaps in there get filled in there, and we let water get into it. When water gets into it, it's going to want to expand and get back to its original shape, just like that sponge did. And when that happens, if I don't have that air to allow that space to get in there, it reminds me of an old friend of mine, Tony, and he was a science nerd. And every time there was an accident, he would always throw out there no two pieces of matter can occupy the same space at the same time. And same thing here. I can't have two pieces of matter occupying that same space, so something has to give, something has to move where it comes to it. Expansive soils, we have two options. One, keep them dry all the time. Or number two, keep them wet all the time. We want to maintain that balance, especially around the perimeter of a home. We don't want to allow those soils to push in or pop up. These are powerful. They've been known to lift driveways, sidewalks, and lift entire houses up when it happens. Pop pools out of ground when it happens. So sometimes you're going to see an irrigation system going about 4-6 feet around the perimeter, and that's going to be your buffer zone. I mean, we can't water the entire earth, but they're going to have an irrigation system about 4 feet away. Now, you're probably thinking, so why am I talking about this if this is only common in Arizona and New Mexico and it doesn't really exist here? No, you are going to have to take a test to get your home inspector license, and that is a national test that you're going to be taking. So it may not have questions about strictly soils that are here in Illinois. Expansive soils is something you should be aware of. Please do a little bit of research on it. I think there's enough said here. All right. So foundations and footings. Let me just see something real quick here. All right. So on the bottom, a few more terms I want you to be aware of. So at the very bottom here, we have the actual footing on here. That needs to be sitting on undisturbed earth. All right. Now, here in the Chicagoland area, we have a lot of basements. We do have slabs. We do have crawl spaces. But mostly we have basements. Why? Because most of our land, our earth here, is clay. All right. It's not until, I want to say 50, maybe 100 feet. I don't know exactly. Do we start getting down into bedrock, all right, where it's solid? But most of it's going to end up being clay. So we don't want to disturb that. We're going to pour, and we don't put any stones or dirt or anything else underneath it when we pour our footing. And then we're going to have, on the footing, we're going to have this little notch right above the red dot there. That's called a keyway. I do want you to recognize it. And this picture is going to show up again later. We'll talk more. Then on top of that, we're going to pour a concrete or stone or brick or block. Even wood. There's a bunch, and we'll get into the different types of foundations that exist. But for the most part, we deal with concrete here. And then we'll pour our basement slab floor. All right. A word I'd like you to write down and remember is all three of these here, this joint together, these are three different concrete pours. And that area is called the cove. And that's spelled C-O-V-E, cove. So first we're going to pour the footing, and then we're going to pour the foundation, and then on top of the footing, butting up next to the foundation, we're going to pour the basement floor. Because they're three different pours, these are all considered cold joints in there. They are not watertight, they are not solid, and as the water starts rising up, it will go through all these, and we will have water enter the basement if it gets up that high. There's no way to keep it out. So what we do is we let the water drain away and we keep the water level below. Water seeks its own level. So if we keep it down below that footing height and we bring it into sump pits, or the house is high enough where we're not worried about the water table getting up that high, then those are ways to keep the water table below the footing height. All right. But I would like you to remember the word cove that comes in there. All right, when we're talking about footings, two more words I'd like you to remember. One is called a spread footing, also known as a strip footing. Typically, we refer to this as the footing, plain and simple. And that's what goes around the entire outside perimeter of everything, of the foundation wall. A couple of rules that there needs to be. I think it's going to show up on the next slide. In fact, let's go to that and then we'll come back. It's the width of the footing needs to be double the width of the foundation wall. All right. Now, since most of our foundation walls are going to be 8 inches thick, doubling that will bring us up to 16. However, most of the areas around here, the minimum width is going to be 24 inches. So even if I had an 8-inch wall on there, I still want to have a 24-inch wide footing. If I had a 10-inch, I'm still going to have a 24-inch footing. If I had a 12-inch wide foundation wall, I'm still going to have a 24-inch footing. If I have a 14-inch wall, now I got to expand my footing and I got to be 28 inches wide. All right. So whatever's bigger, the 24 inches or double the width. Minimum thickness is going to be 10 inches or whatever the width of the wall is. So again, I got an 8-inch wall, I'm still at 10 inch. I got a 10-inch wall, I'm still at 10 inch. I got a 12-inch wall. Now I have to be 12 inches thick when it comes to it. Pad footings are what we put underneath posts or staircases, and this number on here is a minimum number, all right? So it has to be a minimum of 12 inches thick and a minimum of 3 feet by 3 feet wide, all right? It can't be smaller than that. Now, these numbers that I'm talking about are for new construction, all right? You're going to go into homes that are built before World War II, and these weren't the codes or the rules back then. So sometimes you're going to see little square concrete posts that were built underneath these things, and they'll go deep into the earth until they get to some clay or sand or whatever the earth is underneath that building at the time. And that's all it's going to have. They won't be 3 feet by 3 feet. But that's the way it is. And just because the codes change doesn't mean that you have to change the building construction. And if it's working, we're doing this in 2021, and we're talking about houses that were built in 1940. So if it was able to hold its own weight and not settle or move for a period of 80 years, I think we're good. I think it's going to continue doing what it's supposed to be doing. However, it's settled and we have to make adjustments, then we have to make adjustments, plain and simple. So I would like you to know the difference between a spread or a strip footing and a pad, basically. And then again, don't forget we have our keyway up here in the middle. I do want you to remember double the width of whatever the foundation wall, however, not less than 24 inches. And then the height is going to be the same as whatever the width of the foundation wall is, but not less than 10 inches. 2 more words, piles and piers. I would like you to know the difference between those. Piles, I always go back to the World Wrestling Federation when I was younger. I don't even know who the wrestlers are today, but back then Hulk Hogan was a big guy, and he did what he called the pile driver, where he would turn a guy upside down and go straight down with his head, onto the mat and do a pile driver into the earth. And that's what these are. And they basically work off of friction, or as it's shown on the right-hand side, until they hit a solid surface, all right? We still drive piles into the earth today. It's a very common repair for houses that are settling, that are on bad earth. So what they'll do is they'll go down usually on the inside of the house, and they'll put a bracket underneath the footing of the house from the inside, and then they'll have a hydraulic pressure that just keeps pushing rods, and then they'll screw more on there, push it down, until you get enough friction, all right? And think about hitting a nail into a piece of wood, and then all of a sudden it stopped going in, and that nail just, gives away. It just gives up. That means there's so much friction in that wood that I can't move that nail any longer. Or it hits bedrock, and then it goes down there. Once that happens, then they start seeing the house move up, and that's how they know they got either enough friction or bedrock to go ahead and get that house properly supported. So piles are forced into the earth. Think about hammering a nail into a piece of wood. Think about when bridges are being built and they keep taking those steel beams and you hear boom, boom, boom. That is actually a pile driver, and they're driving that pile into the earth. All right. So whether they do it with hydraulics or a gigantic hammer, either way, those are piles when we're forcing them into the earth. Anytime I do any sort of digging, if you ever put a fence in there, you're going to get a post hole digger, or if you're going to dig a trench to put our spread footings and our foundation wall in, those are piers, all right? Even though we install piers in water, where we're going to use piles to do it, but anytime we dig into the earth and then we pour our supports in there, those are known as piers. I would like you to remember the difference between a pile and a pier. A pile is driven or forced into the earth. A pier, we're going to dig the earth out and then put our support piece in there. All You're going to see the leaning stuff come up over and over again. In fact, some of these slides you're going to see become repetitive when it happens, because it doesn't really matter if we're talking about our foundation or rafters or whatever, floor joists. All of these things come into play. All right. I would like you to remember a 1/3 rule. On the exteriors class, I know I talked about this on foundation walls. All right. So anything that's plumb doesn't necessarily have to be 100% plumb. And when I use the term plumb, I mean straight up and down. So gravity is forcing straight at the very top. All right. There is an acceptable amount of a lean or movement where it comes into it. You are going to be tested on this. I'm pretty positive it's going to be in there. But nonetheless, you should know what it is anyway. All right. So whatever the width of that item is, if it's leaning more than 1/3 of its width, then that's an excessive lean. It's what they refer to as the domino theory. So if I take a domino, I stand it on end. Once I start pushing it, and maybe I should push from the other side because I can't bend my hand that far back. I start pushing, and once I get over 1/3 of its weight, now gravity is going to start helping it and taking over, and that's when it becomes unstable. All right, and it's going to want to fall over. So 1/3 of the width of an object, whether it's a post, a retaining wall, a foundation wall, 1/3 of that object, or 1/3 of the width of the object, is when it's too far. Wood rot just weakens up the structure itself. All right, I don't know what much more to say. Even sort of cracking, in fact, any type of damage where it comes to any part of the structure. Here we're talking about the foundation. And we're going to go into reading cracks a little bit later, and I'm going to go back up on the whiteboard, and hopefully you'll pick something up on that. Brick overhang being excessive. Anytime we don't have brick stacking up directly on top of each other, that's called corbelling. I would like you to remember that word as well. Corbel, Corbelling. At least I'm pretty sure that's how it's spelled. It doesn't have to be directly on top of it, but we have the same rules. That 1/3, again, of whatever the width of it is going to be, that still comes into play. So if I want to work my bricks over so they go over on an angle, I can do that. All right, and it's designed to do that, and it will be strong. All right, but if I start going more than 1/3 of the width, and typical bricks are 8 inches by 3 inches, and I get there's different size bricks. All right. But typically they're about 3 inches wide. So if I'm, 1/3 of 3 inches is 1 inch. So I shouldn't be stepping out or corbelling more than 1 inch when it comes to it. There's different types of foundations. I'm going to scan over these next few pictures relatively quickly, and then I would like to come back and talk about each one independently. All right. So the first one, we kind of saw this picture before, is our concrete foundation. This is kind of our bread and butter, what we're going to be seeing most of the time. The second one is going to be our brick structure, our brick foundation, and that's going to be found on older homes. My home was built around 1900, and we have a brick foundation in this house here. All right. Homes older than that, they built the foundations with stones that they stacked them up in there. And then newer construction, we're starting to use wood as our footings, and we're using wood as our foundation walls. And we actually have areas here in Chicago where they have wood foundations. So we'll talk about those and what to look for in a little bit. All right. So let's go back to our concrete foundation, and we'll work again our way from the bottom and work our way up. We talked before about the footing and the keyway, and those are the items that we have down here, our footing and our keyway. Then we have our foundation wall, and again we're stacking everything. We're letting gravity be in there. Our biggest worry is that we don't want to let the bottom slide out or push in. We don't want to let the top slide out or push in. All right, and if we have a crack in the middle, we definitely don't want it to start acting like a knee and get a bulge in the middle and then end up having something like this happen on it. All right. So we need everything to stay up and true that comes in there. But concrete foundations are pretty much our mainstay. When we talk about protecting foundations and protecting the water that comes in there, that's where our drain tiles come into play. Now, this area here, we wrote on there about backfill, and I kind of call that the overdig. So when this pier was built, we had to dig out that earth to get to the depth that we wanted this footing to be located at. All right. We usually dig out 4 feet to the outside. Sometimes we dig out the entire inside if we're going to be having a basement. But the outside of that, we usually go from the foundation wall. We give ourselves 4 feet. And that's room for people to put the forms in. They could walk around comfortably, safely. They're going to do some shoring if need be. But that's what all those items there are for. And then once we get the foundation built and everything's stabilized again, and usually our floor joists are back in there, we have to replace that earth. We have to put it back in there, all right? And I remember some old, they weren't old, they were public work guys, but they're friends of mine that when they go in there and they fix the water mains, they have to dig down to get to the water mains. And they always made the comment, it goes, yeah, that dirt never goes back in the same way it came out, all right? So because of which, this backfill is going to be filled with water, or air gaps, I should say, instead of water. The dirt isn't going to be as compacted and tight. You got to remember, before these machines went in there and dug that earth, it was there from the beginning of time. If nothing was ever built there before, that earth was there for thousands and thousands of years. All right, it was compacted, and gravity would keep causing it to compress over time, and water would get into it and things. It is absorbable, but it didn't have free air spaces in there that allow that water just to flow straight down to the bottom. That didn't exist, all right? But now that we removed it and we put it back, now we got air gaps in there. So if we allow water to land, and again, this is about 4 feet right in here. If we allow water to discharge right here, there's a real good chance it's coming right down to the cove. And if my drain tile isn't there, or it's clogged or damaged in some which way, now my water level is going to start rising up, and it's going to start working its way to the inside. Or, if I got a negative pressure and I got cracks in it, I could actually start getting water coming right in through those cracks in the foundation wall as well. All right. So we try to get our water past the overdig, past where that backfill is. So when home inspectors start saying, well, the discharges should be 4 to 6 feet away, I'd like you to know why. All right. Now we take this same home, such as my house here, when it's 100 years old, that may not be such a factor any longer. Now we're not going to know that. All right, we're just going to be making assumptions and guesses. But if I got water discharging right next to the foundation, and I don't have any signs of settlement inside the foundation, I honestly can't, encourage people to extend those gutters that far away. All right, if it's been that way for a while. If I see where it's causing a problem, then of course we're going to go ahead and do it. But we have a lot of flat surfaces in the Chicagoland area, and these homes aren't brand new. Some are older. And if we're discharging on an older home and everything's kind of done and it's not causing water seepage or anything else in there, I'm not going to encourage somebody to proactively extend gutters, unless something has changed or is new. But anyway, I digressed. Concrete foundations are poured concrete. We have wood forms. Put it in there, let it cure, let it harden, and then we remove the wood forms, and the concrete supports everything above it. Older homes, they dug out the foundation and the backfill, and then we put the masons in there. What's interesting about here, if you look at the bottom, they're, the bricks, or the footings, were actually made out of bricks. And when we remodeled our basement and we dug down to put a drain tile around the outside, it was actually pretty cool to see those bricks perpendicular or in a roll-lock pattern, I guess, being used for the footings. And just like what's shown in this drawing, they were two courses underneath there. They were wider than what the foundation wall is. In this home, our foundation, because we're wood frame, our foundation was only 2 widths, W-I-T-H-E, 2 widths thick. In this drawing, they're showing 3 widths, all right? So the term width stands for this stack going up and down here. That's 1 width. This is 2 widths. This is the third. This is a true brick wall. Yeah, I have no idea if I'm losing something here on my connection or what's going on. So if you're jumping all over the place, I apologize. I'm going to try and keep going. But there might be a little bit of an issue going on here. The third one is going to be stone foundations. And these, this drawing of these diagrams are showing the stone going straight up and down. All right. That doesn't happen. These typically don't have their own footing. What you're going to find is on the stone, they're going to stack in more of a pyramid shape. So when you're in the basement or cross base looking at it, you're going to see these walls leaning, and that's normal. So the inside is going to lean this way, and then under the earth is going to be leaning the other way as well. All right. So this drawing's a little bit off when it comes to it. Now, neither the brick or the stone or the blocks are designed to be waterproof membranes. So we have to allow that water to drain down below and be, removed from the area. Otherwise, it's just going to keep working its way into the house, plain and simple. All right. Wood foundations are, kind of unique. I found a subdivision in Hanover Park, Illinois. Kind of a little bit on the north side, but mostly west suburbs when we come in there. And they have a whole subdivision where the builders were allowed to put in wood foundations. So when you're going around the outside, you're actually seeing that wood foundation. I'm going to see if I can make things here stop. Yeah. So my screen on here is not showing changes. And I got a feeling that I'm having some technical difficulties. So I'm actually going to stop this right now and see what I could do to fix it. Well, looks like, yeah. And then I'll try and restart this thing again. I'm sorry.